Okay, now recording. Okay, while I set up the shared screen, this is one of those days where I have to end early again for things to do in the afternoon. So we will definitely finish somewhat early. So getting set up. So it's up to you and it's up to Star. I know Star, you're with me. If you want to arrange something for preparation for the test. And I haven't had a chance to tell Mackenzie, but Mackenzie will join us a little bit later. If any of you want to review for the exam, you may. I'll have to leave after a certain amount of time, but you're always welcome to review with Mackenzie or Star if they're willing to have a special session for you guys. Okay. Now, I've already covered everything we need to cover for the exam. So reminder of our little calendar, it's all messed up now, but Thursdays are tests, exam 5. Coverage is chapters 9 and 10, of which I'm finished now. Okay, it's all trig. So I'm going to get started with 11.1. So our last test will cover 11.1 all the way to 13.5. There's very little trig there. I'm not going to say there's no trig, but the majority of trig is over after this. Okay, so I'll go ahead and start 11.1. In fact, I'm going to go ahead and mark it off. My game plan is to do 11.1 or as much as I can. Okay, and we'll just go maybe one section a day or so. Remember, Wednesday, if you want to have any questions, preparation for the test, you be sure to bring it up on Wednesday. Okay, Thursday, the next test, I'll lecture, quote unquote, a short while, very short time again, questions and answers, break, and then test. Okay, so I'll try to start the test at 12 or earlier, but if you want to start early, which most of you have been willing to do, if there are a few questions, we can go ahead and start the exam a little bit earlier. Okay. Then after that, we just have one more test and a final exam. Okay. I'm going to try to aim for the last regular test to be Wednesday, May the 19th. Okay. That way we can have one day for review on Thursday the 20th. Okay. So I doubt it's going to be here, but we'll see. Maybe I'll finish early, then we have more days for review, but it's flexible. Maybe I should say the latest I want to have the last test is on Wednesday the 19th. Because I want to leave at least one day for review. Okay, and this is our final exam date, Monday the 24th of May, 11:10 to 1:40. Okay. All right, but our upcoming test this coming Thursday will just be on chapters 9 and 10. Put together your cheat sheet if you haven't already done so. And just like all the other exams, you know the way it's been working now. So you've seen 4 exams already. So we have exam 5 and exam 6 to go. All right. So any questions about that before I get started? Let me check the chat. I don't see anything in the chat right now. So if not, I'll go ahead and start today's lesson, which will again not be on this test. Although there's a lot of review. Frankly, a lot of this stuff is review of old material. Chapter 13 has a lot of new stuff, but I think today's stuff is almost all old stuff, and likewise for 11.6. Okay, and again, we'll finish somewhat early today. I have to go to do other matters. So any other questions, please? Okay, so let me start 11.1. Again, so you can kind of take notes, but look at it somewhat half-heartedly. I know you're focusing on the trig from 9.1 to 10.2. So don't look at anything I do this week too carefully until after the test. And after this week's test, and you can go ahead and start preparing for the last test. Okay, so 11.1, it's a review of systems of equations. Which you should have seen in at least 2 other classes, Algebra 1 and Algebra 2. I'm going to say you've all had Algebra 1 either in high school or in college somewhere, and Algebra 2, or more commonly sometimes referred to as elementary and intermediate algebra. Okay, so we're reviewing systems of equations. Sometimes we call them 2 equations and 2 unknowns, 2 linear equations and 2 unknowns. Sometimes written like this: ax plus by equals c, dx plus ey equals f. Just give me different numbers for a, b, c, d, e, and f, and you have a so-called system of equations, 2 equations and 2 unknowns. Okay. Now, graphically, you might recall graphically when you have 2 equations and 2 unknowns, the most common occurrence is figure 2, page 759. They touch at one point. Figure 3 might also happen. You have sometimes called an inconsistent system. There's no solution because the 2 lines are parallel. In figure 4, you have a consistent system with infinitely many solutions. So you graph the first line and you graph the second line, you say, hey, they're the same line, they lie on top of each other. So you have infinitely many solutions, remember that? But by and large, the vast majority of the time, you get one solution. You draw one line, you draw the other line, they touch at one point. Okay. We're not going to focus on the graphing technique. Okay. We're going to focus on substitution and elimination. Okay. Sometimes elimination is called the addition subtraction method. Okay. You may not have heard of that, but once we get started with some of the problems, you should recognize them pretty much right away. Okay. So I dare say everything we do today is review. There should be nothing new. Okay. So we're going to do some problems by substitution. We'll do some by addition, subtraction, and then there's some word problems at the end that we'll get to. Okay. All right. So here we go. So we got 11 to 17, 21 to 27, and 3 word problems, 35, 36, 37. But I'll try to show you at least a couple of them. Maybe I'll get to all of them. Okay. Now, when I'm lecturing on this, I will assume you've seen it before. So I'm not going to lecture as if you've seen it for the first time. This should not be the first time you've seen it. You should have seen it in at least 2 other courses, elementary algebra or intermediate algebra, as it's called in college, or maybe algebra 1 and algebra 2 in high school. Okay. So first thing I do is I always do is show you the picture of the problems in case you don't have the book and aren't getting it. So on page 766, so we had to go up to problem 37. So let me try to show you that. So 11 through 17. There's that. Remember doing problems like that, hopefully. And then, so there's 11 through 17, substitution. Then 21 to 27 says addition, subtraction, sometimes called elimination. Okay, and then the word problems 35, 36, and 37. 35, 36, and 37 mixture problems. Okay, so there we go. All right, so let's get started. And as usual, I'll end up doing a lot. So again, you know, my requirement is you have to submit at least 70% of the homework. But that's really a joke because I do such a great percentage of the homework anyway. That's that if you just copy exactly what I did, then you have very little to do beyond that, right? How much do I end up doing? 50%, 30%? Sometimes I literally do 75% already. So it shouldn't be that hard to submit, 70%. Okay. And likewise today, I'm going to end up doing half or more than half of these problems. Okay. All right, so here we go. Today is the 26th. Okay, we only have about 4 weeks left, folks. You just count them down. The end is in sight. 1, 2, 3, 4, and then we have a final exam. So only about a month left. Hang in there a little bit longer. Okay, so we're doing what? 11.1. If I get my pen to work. Page 766. All right, so we're supposed to do 11 to 17. I'll start off with number 11. (4x minus y equals 7). Negative 2x plus 3y equals 9. All right, so right now it says solve by substitution at the top there. Okay. Substitution. Okay. And of course, for the exam, not this coming exam, but the next exam, which will be our last exam, if it says solve by a particular method, you're supposed to do that method. So if it says solve by substitution, do substitution. If it says solve by elimination or addition, subtraction, you got to do it that way. Okay, what is substitution? For substitution, you solve for one variable in terms of the other. So solve for one variable in terms of the other. And just bear with me a second. I'm a little bit tangled up here. So but the wires kind of tangled up, so I had to untangle them. All right, solve for one variable in terms of the other. So in other words, make it look like y equals whatever or x equals whatever. Okay, so isolate a variable. Now, I see a y that doesn't have any coefficient except for a -1. The x here has a 4, this x has a -2, this x has a 3. It's easy to solve for y in the first equation, right? Because there's no coefficient there. To solve for x, I'd have to divide by 4. To solve for x here, I'd have to divide by -2. To solve for y here, I'd have to divide by 3. Anytime you divide, it means you might get fractions. I don't want fractions. So we'll solve for y in the first equation. So 4x minus y equals 7. Okay, now again, I'm assuming since we're in pre-calc, your algebra is very good. I'm just going to move that over there, move that over there. It says 4x minus 7 equals y. Okay, so this means if I add y and subtract 7, the equation looks like this. Y equals 4x minus 7. I trust you knew what I did there. Again, if you were in my Algebra 1 class, I wouldn't go that quickly. But since you're past that stage, you know what I did. So I isolated y. Solve for one variable in terms of the other. I've solved for y, right? So now that I solve for y, I pick up this expression and plug it into the other expression. Don't go back to the original expression. You won't get anywhere. Okay, I worked on the first equation. Now I plug into the second equation. So -2x plus 3y, -2x plus 3y equals 9, right? Again, -2x plus 3y. But I don't write the letter y. I write what it's equal to. What is it equal to? 4x minus 7. So I put 4x minus 7 right in there. And now look, I only have one variable, right? That was my object. I don't want to have two variables, x and y. I just want a single variable. So now I can work this out. I'll get x equals blah, 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 blah. Take that answer, plug into either equation, and then I can find y, and then I'm done, right? Remember doing stuff like that? So again, substitution, solve for y. It's easy to solve for y in the first equation. There's no coefficient in front of it except for 1 or -1. Again, if I try to solve for x, somewhere I have to divide by 4, fractions. If I tried to solve for x here, somewhere I have to divide by -2, fractions. If I try to solve for y here, somewhere I have to divide by 3, fractions. I don't like fractions. I'm guessing you don't like them either. So here, I don't have any fractions, at least not yet. Okay, so let's finish this. -2x plus 12x minus 21 equals 9, right? Plus 21 plus 21, 10x equals 30, so x equals 10. So we found x equals 10. I'm not done. I need an ordered pair. I need x and y. So plug into either equation. I don't know. How about I plug in 10 over here? You can plug into this one also. Let me plug in 10 here. So -2 times 10 plus 3y equals 9. That's -20 plus 3y equals 9. Add, let's see. What did I do here? X is equal to 3. What am I doing here? Not 10. X is equal to 3. Messed up, right? 10x is, yeah, x is 3. Sorry about that. So botch this all up. Plug in 3. Negative 2 times 3 plus 3y equals 9. Okay, that's more like it. That's negative 6 plus 3y equals 9. Add 6. 3y equals 15. So y is equal to 5. So as an ordered pair, 3, 5 is the solution. And remember, it should work for both equations, 3, 5. And let's double check. Put a 3 here. 4 times 3 is 12. 12 minus 5 is 7. That works. Put a 3 here. Negative 2 times 3 is 6. Plus 3 times 5 is 15 equals 9. It does work. Okay. So I caught myself. I messed up over here. And what led me to that was when I was plugging in and saying, hey, I'm not getting the answer. Something's wrong. Okay, but now I know it's correct because when I plug in, it works for both of them. Okay. So this was substitution, right? I'm sure you've seen that before. So we'll do another substitution kind of problem for you. Okay. Now, sometimes you don't have any choice of what to pick, especially if they give you fractions. So 15 is really not nice. It already gives me fractions. 3/2 x minus 5y equals 1. I'm already not liking it. X plus 3/4 y equals 1. Okay. Double check that I did it correctly. All right, so just like this one, is there any variable that does not have a coefficient in front of it, or strictly speaking, a coefficient of 1? This one, right? Solve for x. It doesn't matter if you solve for x or y. Okay, so if I move this over, I got it, right? X equals 1 minus 3/4 y. The only thing that's clumsy is the fractions. So I'm stuck. Just got to live with it for now. Okay, now I'm going to pick this up. Put it right here. So it'll be 3/2 x, but instead of writing x, I'll write this thing. 3/2 x. There's x, right? Minus 5y equals 1. Okay. And once again, I got it down to a single letter. I don't have x and y, I just have y. Unfortunately, it's a fairly complicated equation, but that's the best we can do for now, right? Okay, so distribute 3/2 minus 3 times 3 is 9, 2 times 4 is 8, 9/8y minus 5y equals 1. Right? And let me see if I did that right. Okay, so far it looks good. All right, I really don't like all those fractions. I think you don't either. So let's clear the fractions. What's a good common denominator? 8. Multiply both sides by 8. Now you say, can I just get a common denominator of 8? You can, but I like no denominator. No denominator to me is better than common denominator, right? That means no fractions. So when I distribute, I won't have any fractions anymore, at least until maybe the final answer. Okay, 8 divided by 2 is 4. 4 times 3 is 12. 8 cancels 8, minus 9y. 8 times a negative 5y is negative 40y equals 8. All right, no more fractions. At least in the equation that I see right now. Okay, subtract 12, subtract 12. -9 minus 40, -49y equals -4. And that's really going to be a weird answer. Four over 49. Well, that's the way it is. That's the way it is. And how about I plug back into here to find x? X is 1 minus 3/4 of 4 over 49. Oh, these cancel out. So I have 1, which I'm going to write as 49 over 49 minus 3 over 49. So 46 over 49 is my weird answer. All right, so final answer as an ordered pair. 46 over 49, 4 over 49. And that's the best we can do. Okay, now 11, it was pretty easy to say, oh yeah, solve for y. Here, it's pretty easy to say, okay, solve for x. But see, some problems you don't have any choice. Like 13 and 17, there is no choice. There is no coefficient that has just x or y, so you have to divide. You know, there's no way around it. Okay, so that's the way it is. That's the way it is. Okay, so I'll do 17 for you, and that'll be it for that type of problem, hopefully. For x plus 6y equals 3, negative 6x minus 9y equals negative 9/2. Okay, so there's no way around it. I got to divide somewhere, right? For this first one, say, oh yeah, I can solve for y. I might have to multiply by -1 or move, but you know, the coefficient's either 1 or -1. This one, say, oh yeah, x is fine. Here you're stuck. If you're going to solve for x on the top, you must divide by 4. If you're going to solve for y on the top, you must divide by 6. If you're going to solve for x in the bottom, you must divide by -6. And if you're going to solve for y down the second one, you have to divide by -9. So we're stuck. So which one should I pick? Well, I pick smallest number that's positive, I guess. So let's aim for this one, right? Smaller number and positive. So how do I solve for x? Subtract 6y, right? So 4x equals 3 minus 6y. And then divide by 4, divide 4, divide 4, divide 4. X is 3/4 minus 6 over 4 reduced to 3/2 y. Right? I'm stuck. I got no choice. They didn't give me nice numbers. So there we go. Okay, pick this up, plug it in the other equation. So it's -6x, but instead of writing x, I'm going to write all this stuff. And then minus 9y minus 9/2. Okay. So that's the way we've got to do it. So -6, blah, 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 right? So -6 parentheses, whoops. 3/4 minus 3/2 y minus 9y equals -9/2. Okay, this stuff right here is x. Okay, I'm supposed to go -6x, right? But instead of writing x, it's -6 times all this stuff. And then I just copy the rest. Okay, so let me distribute. Oh boy, let's see. -6 and a 4. Well, that's going to cancel, give me -3/2. -9/2. -3 times 3 is 9. -9/2. Right. Plus -6 times -3 is 18. Divided by 2 is 9. Look at what happens. All the variables are gone. I get -9/2 equals -9/2. Remember what happens in that case? This is the case of infinitely many solutions. Infinitely many solutions. Graphically, it means the lines coincide. Okay, that would be like this picture that showed you earlier. Page 759. That one. If you were to graph them, the lines lie on top of each other. Okay, so that happens whenever you get all the variables canceling out, but you get a consistent equation. -9/2 equals -9/2. Okay, now suppose you get two different numbers and everything cancels out, like it says 0 equals 1. That would be inconsistent. That'd be figure 3. The lines would be parallel. You'd have no solution. Remember that? So that might happen. Okay. All right, so that was the substitution method. Okay, and let's see. Okay. Question about x equals 3. I think if you're talking about the one I messed up on, number 11. Yeah, I goofed. So yeah. All right, so that was a quick review of the substitution method. And now the addition subtraction method. Okay, which I'll go straight to since I'm assuming you've all seen that before. I think you'll probably like this better. Okay, so substitution was 11 to 17. And now 21 to 27, addition subtraction. So let me show you some of those. So 21, please. 5x plus 6y equals 4. (2x minus 3y equals -3). Okay, this is pretty much to show you, you really don't want to do substitution in this case if you had a choice, because that's sort of like the previous one, right? If you do substitution, say, oh, I got to divide by 5, or I got to divide by 6, or I got to divide by 2, or divide by -3, you're going to be stuck with fractions. Okay. Instead, line up either the x or the y coefficients. One's a positive and one's a negative. So then when you add up the equations, you get a cancellation. Okay. So I see 5 and 2. That's not very convenient. But yeah, I see the 6 and a -3. If I multiply that second equation by 2, right? Multiply this by 2, this will become a -6y. And then when I add it to the positive 6y, they'll cancel out. Right? Remember that? Okay, so this is sometimes called the elimination method. Maybe I should have written that down first. Elimination method, same as addition subtraction. Okay, so leave the first one alone, multiply this equation by 2. You say, what am I doing that for? That way, this is going to be 6y. This is going to be a -6y. Remember that? So when I add them up, I get a cancellation. So leave the top equation alone. Don't do anything with it. But change this one 4x minus 6y equals -6. Now I'll just add them up. When I add them up, y's drop out. And 9x equals -2. And looks like I'm stuck with a fraction again. X equals -2/9. Right? Remember doing stuff like that? Now I got to go back and find y. Oh boy, what do I want to plug into? How about I plug in the top one because it's all positive? So at least there's only positives. So 5 times x, 5 times -2/9 plus 6y equals 4. -10/9 plus 6y equals 4. Really don't like all those fractions. So how about I multiply both sides by 9 just to make my work a little bit cleaner. So that's -10 plus 9 times 6 is 54. Y equals 4 times 9 is 36. Add 10 to both sides. 54y equals 46. Boy, these numbers are bad. Divide by 54. Y equals 46/54. And let's see, I can divide out as 2. 23/27. So if I did it correctly, -2/9. 23/27. Now, if you do the work correctly and you get the wrong answer, hey, I can get the wrong answer, very, very easily. So you get most of the credit if your logic is good. So if your logic is good, you made an arithmetic mistake, welcome to the club. I make arithmetic mistakes all the time. So, as you can see, I messed up already over here. But that's the principle, at least. Principle is, get either the y's to match up in coefficients or get the x's to match up. One's a positive, one's a negative. Okay. Then when you add up the equations, you get a cancellation, right? Remember doing stuff like that before? Okay. Now they make it a lot harder on us with something like fractions, right? Or decimals. So look at how bad 25 is. So my first order of business for that one is to get rid of the fractions for 25. What even says there, hint for exercise 25, clear both equations of fractions. Okay. So how do we do that? One-fourth x minus 1/3 y equals 4. 2/7 x minus 1/7 y equals 1/10. All right. Don't like the way it looks. I'm guessing you don't like the way it looks either. So multiply both equations by something to clear out the fractions. Okay, common denominator here. 4 and 3, 12, right? I multiply by 12, I'll clear that fraction, I'll clear that fraction, and this already isn't a fraction, so that's good. Okay, 7, 7, 10. Good common denominator. 70, right? Multiply both sides by 70. That will clear that fraction, it'll clear that fraction, it'll clear that fraction, and then it's something that hopefully I can work out. So 12 divided by 4 is 3. 3x minus 12 times -1/3 y, -4y equals 4 times 12, 48. Okay, let me pause and get the curl out. Okay, and what was this one? Was it 2? So 70 divided by 7 is 10. 10 times 2 is 20. 70 divided by 7 is 10. So 10y equals 1/10 of 70 is 7. Okay. So it's still not nice, but at least there's no more fractions, right? So I can go from there. All right, I'm stuck. I have to multiply both equations again by something. So how do I get these to line up? How do I get these to line up? So 3 and 20, I can make both of these 3 times 20, which is 60. That's a little bit too big for my liking. Let me try to work on this. 4 and 10, how about let's make them both 20 with one positive and one negative, right? Okay, so how about multiply the top equation? And one of them's got to be positive, one of them's got to be negative. So how about multiply the top equation by -5? And multiply the second equation by 2. Right? So that's going to force this to be 20y. That's going to force that to be -20y. -15x plus 20y equals 48 times -5. Punch it in your calculator. -240. And then the second one, 2 times 20x is 40x minus 20y equals 7 times 2 is 14. Add them up. Okay, y drops out. 25x equals -226. Really bad fractions. Divided by 25. X is -226 over 25. Not very nice. Okay, let's try to find y. So I don't want to plug back into these guys. So how about one of these? Maybe this one. Okay. So 40x, 40 times -226 over 25 minus 20y equals 14. Man, this is bad, right? I can take out a 5. Take out a 5, that's a 5, that's an 8. So 8 times a -226. 8 times 226, -1808. Divided by 5 minus 20y equals 14. Let's multiply both sides by 5. -1808, the 5's cancel out. 5 times -20y, -100y equals 14 times 5, which is 70. Add 1808. -100y equals 70 plus 1808 is 1878, right? Divided by -100. Y is -1878 over 100. And I can divide out a 2, I guess. -939 over 50. So a really weird ordered pair, right? That and that. -226 over 25 Negative 939 over 50. Okay. All right, I've reached the end of my paper, so let me do my focusing thing. That second column. Third column. And the last column. And by the way, if I ever get to this and you say you can't see it, if I'm going too fast, let me know. Okay. But again, I'm assuming you can always pause the video. And so speed should not be an issue as long as you can focus it just for even 1 second and go on from there. Okay, what time is it? It's almost break time. Maybe set up one more of this type and that's about it. Okay. Then 27 really is a nice relief after those weird ones that we had. (27) 8x plus 16y equals 5. (2x plus 5y equals 5/4). This should be much better. Much, much better. Okay, which coefficients do you want to match? X, right? 16 and 5, one doesn't go in the other easily, but this is 8, this is 2, so I should multiply this equation by -4, right? Not +4, then they'll both be 8x. I want this to be -4, so when I add it up, they're going to cancel, right? -4, -4. Leave that alone. Second one is -8x. -4 times 5y is -20y. And 4's cancel out, I get -5. Add them up. Cancel. -4y equals 0. Well, if -4y equals 0, that means y equals 0. Very nice. So put the 0 back in here because that one doesn't have any fractions. So 8x plus 16 times 0 equals 5. 16 times 0 is 0. 8x equals 5. So x equals 5/8. There we go. So 5/8, comma 0. And there we are. All right, so it's our usual break time. So we won't go that much longer after the break. After the break, we have some word problems. That might take a little while. So I'll just do a couple, but we'll definitely finish early since I have to get going. Okay, so we'll break into our usual 10 after 12 roughly. Okay, all right, we'll take our break.
Professor Holm, you're on mute.
Can you hear me now? Yes, you
Yes.
okay, somebody here. Okay. Let me get back to where I was, but thanks. Okay, the second half will not be that long. I was going to do 2 of the word problems, and then I have to close up session. And Star and Mackenzie, I'll leave it up to you if you want to put in the chat some review sessions you might want to have in preparation for the test Thursday. So again, everybody, we are still having our test Thursday. It will not cover the stuff I'm doing today or tomorrow. I've already finished all of that. Okay, so exam Thursday. Okay, so I'm doing 11.1. I'll be finished shortly. Do a couple word problems, and that's about it. Okay. All right, so it's up to you, Star and Mackenzie, if you want to give any times for this week that you have a review session. Go ahead and put in the chat while I lecture. That's up to you. You know, do whatever fits you folks' schedule. Okay, but we won't go much longer. I'm basically going to do 2 word problems, and then we're done for the day. Okay. All right. Remember doing these kind of problems. So 35, 36, and 37. Let's look at 36 because it's an even problem. One salt solution is 15% salt, another is 20% salt. How many cubic centimeters of each solution must be mixed to obtain 50 centimeters cubed of a 16% salt solution? Okay, so how do I do stuff like that? Let's put down the information that we know. Okay, so we have 2 mixtures. Call X is the amount of one type. So the one type, it says, is 15% salt. And how about Y is the amount of the 20% salt? Okay, so I'm mixing them up. And when I mix them up, I have 50 centimeters cubed total. That means X plus Y equals, what was it again? 50. Now the total amount of salt has to add up, which is 15% of X. That's what it means to be 15%. 15% is salt. So the salt here plus the salt here is the total salt. How much salt is here? 0.15X, because it's 15%. How much salt is here? 0.20Y. And that's equal to the total amount of salt, which is said was 16% of 50 centimeters. Here's my 2 equations. Okay, so I have a mixture of 15%, I have a mixture of 20%. It said there's a total of 50 cubic centimeters, cc's. So X plus Y is 50. The total amount of salt has to add up. So the amount of salt here is 0.15X, that's why it's 15%. The total amount of salt here is 0.20Y, and it's equal to the grand total, which is 16% of the 50. Okay, so I'm gonna have 50 cubic centimeters at the end, but only 16% of it is actual salt. Okay, so there's my 2 equations and 2 unknowns. Now, I don't like all these decimals, so let's multiply by 100. Okay, now thinking ahead, this is going to be 15X, this is going to be 20Y. So I want this to be a negative 15X or a negative 20Y. I usually like picking a smaller number. So multiply this one by negative 15, like that. Okay. So the top equation is negative 15X minus 15y equals 50 times negative 15, negative 750. Okay, 100 times that is 15x. Plus 100 times 0.20y is 20y. Equals whatever that is. Okay, so what does that come out to be? One 6 times 50 times 100. 800. Add them up. 5y equals 50 divided by 5. Y equals 10 cubic centimeters. Just put cc. Of which type? So label your answer of the 20%. So 10 cubic centimeters of the 20%. Therefore, what is x? Well, they told me the total amount is 50. So if I've got 10 here, then the other must be 50 minus 10 or 40. 40 cubic centimeters of the 15%. And that's it. That's my answer. All right. So column X and Y. X is the amount of 15%. Y is the amount of 20%. The total was 50, so X plus Y is 50. The amount of salt has added up. So 15% of X, because it's 15% salt, 20% of Y, 0.20Y, is equal to 16% of the 50. And then I solve. Okay, now how do you actually check this answer? Well, the total is 50 cc's, right? That's clear. 10 plus 40 is 50. The tricky thing is the amount of salt. So amount of salt. Okay, so I have 20% of 10 plus 15% of the 40. Okay, so if I add that up, that's going to be 2 plus 6, which is 8 cc's of salt. So the total amount of salt is 8 cc's. Now I'm supposed to end up with 16% of 50. So what is 16% of 50? That is exactly 8 cc's of salt. So it does add up. Okay. In other words, if I have 8 cubic centimeters out of 50, that is 16%. So it does add up. Everything adds up to be the way it's supposed to be. Okay. All right, that's that word problem. I'll do one more word problem and then we're done, folks. So we'll be out of here before 12:30, I think. Okay. All right, so 37, similar kind of problem. A shopkeeper has 2 types of coffee beans on hand. One type sells for $5.20 a pound, the other for $5.80 a pound. How many pounds of each type must be mixed to produce 16 pounds of a blend that sells for $5.50 a pound? Okay, so it's very similar type of problem. So column X and Y. So X is the amount of one type, $5.20 a pound. Y is the amount of the other type, $5.80 a pound. Now, it says the total amount is 16 pounds, problem 37, at $5.50 a pound. So X plus Y equals 16. And then the cost for this one plus the cost for this one equals the total cost. So 520x plus 580y is equal to the cost of the mixture. It says it's 550 a pound, problem 37, times 16 pounds. So 550 times 16. Okay, let's clear the decimals. I don't need to multiply by 100. I think I only need to multiply by 10, right? I just need to move decimal over one spot, and that'll do it. So multiply this by 10, all of this by 10. So planning ahead, that's going to be 52. That's going to be 58, right? Therefore, what should I multiply the top equation by? Negative 52. You could say negative 58, but you know, it's usually easier to pick a smaller number in general. So negative 52, negative 52. Okay, so negative 52x minus 52y equals negative 52 times 16. 52 times 16, 832. And then that's 52x plus 58y equals all this stuff. So 550 times 16 times 10, 516 on my calculator is 880. Add them up. That drops out. 6y equals 48. Divided by 6. Y equals 8 pounds of the 580 a pound. Okay, the total was 16 pounds. So if this is 8, that means the other one's also 8, right? They're both 8. So 8 pounds of the cheaper type, 520 a pound. So that'll do it. Okay, let's do our double check. Okay, so what's the total amount spent? So 8 times that plus 8 times that, right? Okay, 8 pounds at 580 a pound plus 8 pounds at 520 a pound is equal to something, right? So let's work that out. $88. Okay. Right. I take 8 pounds at 580 a pound plus 8 pounds at 520 a pound, add it all up, $88, which should match the total amount here, which is 16 pounds at 550. So 550 times 16, 5.5 times 16, and voila, exactly 88 works. So it all checks. Okay. We're done, folks. Okay, so I'm going to do my focusing thing. If anybody has any question, you can bring it up in the chat. Okay, and so on. And thank you for Star and Mackenzie putting something out. Thank you. Okay, so if anybody has a quick question for me today, I can't stay that long, but get that. So thank you, Star and Mackenzie. Check anything else in the chat. It's hard to read all the chat when you're lecturing. of stuff, but I think everybody sees that. So everybody, please check the chat on what Mackenzie and Star have to say. I'll do my focusing thing and then I'm done. Unless anybody else has a quick question. And yeah, I'm done with that one section for today, but today's stuff will not be on Thursday's test again. Okay, like I did for almost all the rest of the semester. I'm just getting ahead for the next material. Okay, and that's it. So check out where are we? All right, so I'm here 11.1. Forget this original schedule. I'm at 11.1. So tomorrow 11.6. Okay, but you're studying for the test 9.1 to 10.2, and that's what we got. Okay, I'll check the chat. I think that's about it. Anybody else have a quick question? Otherwise, we're done for the day, folks. Okay. Anybody else? All right, then everybody have a good afternoon, and we'll see everybody tomorrow. Okay. All right, thanks everybody. Bye. Have a good day. See ya.